So hello everybody, welcome to DevTest Days. I'll be talking about the software as a product differentiator in the embedded industry. So I'm Santtu Ahonen. I'm working in the Qt company in our office in Finland, and I've been in the past years responsible for our embedded business in our product management. So my topics today, I'm talking about some of the trends we see on the device business. I'm talking about the importance of re-evaluation of things to do and the finding and cutting waste in the organization and how Qt tools can help you there. And then at the end of the video, you can jump the live questions and answer sessions, but I'll be answering whatever questions you may have regarding the topics of the day. So traditionally, embedded product business is working so that the product business is first looking into the requirements and design of how to create the products, then selecting the hardware, then selecting the operating system, and only then selecting the tools and creating the UI and application for the solution, and then implement and test the manufacturing ship. So this is a very traditional waterfallish way of creating hardware products and hardware designs. And it's where many of our customers who are coming from old hardware products and now thinking of adding a software element, maybe a display and a touch display into the product is coming from. The focus of this model is on the bill of material. So it's based on the assumption that you make the value of your business at the time of the sale with the product. And then it's slow to react to the market changes, and you end up with a dedicated team, so every product or product line in the company. And what often also happens is that towards the end of the process, there's a curveball by your procurement, which decides to maybe cut some component or change a component to cheaper because the focus is on the bill of material and the profitability is counted from there. So that may end up in the scenarios, and I have seen that in many companies that, that may lead to a situation that maybe the flashing in the factory takes just a little bit of longer time, but it makes the manufacturing slower. So if you're manufacturing millions of devices, that has a value, or it may impact in the behavior of the UI or the software or the experience of the consumer, which means that the software team will then need to go back and re-implement stuff. And at worst, in this kind of companies, these two different parties don't see each other. So the procurement is getting their bonuses for cutting the bill of material, but then the other team is getting penalties because they are delayed. But actually, it's this kind of end-to-end software creation in the organization. What is happening? So this is like a very typical hardware-driven company making hardware products. And the value is not actually, this is not supporting the value on where the industry is going. So the value and the expectations of the consumers are moving to the UI and into the application. So first look into the expectations. So the consumer, and be that like a consumer of the home appliances, consumer of the business solutions, whatever, are really used of using mobile phones. So the performance and the fluidness of the UI and the overall experience with the applications with displays is really driven by mobile phones. And that's a really difficult target for embedded development, because often compared to mobile phones, the embedded products have very limited hardware capabilities. So achieving similar kind of responsiveness and performance on embedded devices is difficult. Another thing which is happening is that when you are starting to look the world through software, is that you can do stuff you couldn't do before. So the picture I have here is a company who used to have a lot of different sliders and switch and knobs and buttons in their products, but then turn all of that into software elements. So they could then do changes on the design, or if they realize they needed to add a slider or combine buttons or change the behaviors of different elements, they can do that during their product life cycle, or they can even do that post-manufacturing the devices, or at best they can even sell those to the customers as additional features on top of the baseline product. So this is also creating new businesses. So one of the key questions for the old product companies is really the bill of material the right strategy for you? So is it the optimizing the bill of material? So are you creating your value in your business at the time of the purchase and sales of the device, or are you actually, or is your competition already in the model where they are creating value post-manufacturing? So we see companies who are actually selling a device which is a feature-wise minimum viable product, but then it has a huge promise of the future capabilities of the device. And at the manufacturing phase, they are not optimizing the bill of material. They are actually throwing in much more CPU and memory and capacity into the device that they would need at the time of the shipping. And that's because they are preparing for a service business or adding new capabilities into the products. And that could be examples of like, in a car, a heated steering wheel. So the hardware is there at the time of the shipping, but the capacity is not implemented fully, so they can cut the time to market, and then they can turn that into a service that, because the heated steering wheel, let's face it, you need during the winter season, you don't need that during the summer season, so they can get the customer to buy that every year. So they can generate a new kind of business which was not accessible for them before. Or somebody working on the heart rate monitors. The old business was that they make a new heart rate monitor every year, and it has slightly better features and somehow slightly better new models into it, but they were like, you know, shipping more and more on these hardwares into the market. But then they could be approaching this whole business in a slightly different way. So they make a heart rate monitor that can be extended and integrated with other stuff, and this additional other stuff can be sold as services or additional features to the product which is out there already in the market. So one question to ask there is that, are you in a business where optimizing the bill of material is really the core of your strategy for your business? Another trend that we are seeing is that there are disruptions in the businesses. So there are disruptions caused by competition, there are disruptions caused by product change, or today the very topical disruption is the global pandemic with the COVID virus. So what happens if you need to change your hardware? You need to change maybe the display, or there could be an unplanned chipset shortage on a certain silicon. So what if you decide or you realize that you have to change the underlying hardware of your product? So then it really matters how you have implemented your solution and what kind of framework you have selected. Is that a huge overthinking of rewriting everything you have, or is it just a matter of get the new hardware, port it in 5 minutes and get going? So there is a huge differences on different software frameworks. Another thing what we have seen is that 2 years ago, it was not so much of a worry for our customers that how can they add like camera gestures or sensor gestures or voice activation into their solutions. Today, that's quite important topic. So there's a lot of discussion about having less of things to touch, like buttons or touch screens, and having more on things that you can control through different sensors without actually touching the devices. And then if you had the hardware or you were preparing to have like a flexible framework and the flexible tools to cater for that, those are better prepared to address this kind of issues. And today we talk about these things on the pandemic, but there could be other disruptions caused by competition or other situations in your market that lead you into this kind of change, that you need to do changes to your product that you did not plan at the initial design phase. Then a slightly different angle, talking about the not enough of developers and the amount of devices out there in the world. So from Qt, we see that we are inside this tornado of connected embedded devices just exploding all over the place. So they are going to be in all kinds of home appliances, business solutions. They're in cars, airplanes, submarines. So they are all over the place. The world just cannot get enough developers. So it's a similar analogy as the world is pretty much everybody is learning the reading and writing in schools, but very few people actually become authors of books. So similar thing with the universities. So in the universities, almost everybody is taught how to do programming, but very few people actually become programmers. So since the world is exploding in the number of connected devices, there needs to be ways to make those few developers more productive, benefit from work done by other developers, not to write 100% of their own code on themselves, but maybe just write less and deploy more. So write 5% of the application logic and use the 95% of the work that is already being implemented and done elsewhere. And that's actually the business we are in Qt on enabling those developers to be more productive. One more thing, looking into this kind of a different considerations, a re-evaluating of your business and the basic underlying needs is to look into the evolution, that how did I get here? Where are we currently with our products? Because often products in the older businesses are an outcome of an evolution, which is like a fractal going forward. So you, in the evolutionary way, you make the decisions, case by case, and you are not going on a straight line. You are going on a slightly curvy line on left and right. Great example of that is ourselves in Qt. We did the Qt 5 in 2012. At the time we did the Qt 5, the underlying hardware rendering interfaces was basically just OpenGL, and it was only about 2D interfaces. Since then, world has changed. World has changed quite radically. Today, the UIs are about integrating 3D and 2D into the UIs, and then it's about, there are multiple different rendering hardware interfaces underneath. So Vulkan, Metal, Directly, OpenGL. We, even though Qt 5 was supporting those quite well, it wasn't initially designed for those. So with the Qt 6, we got rid of a lot of the legacy old payload, and we could make like a clear and much better architecture to suit us for the next 12 years. On our path on this. So similar to what we did, you need to reevaluate every now and then your software and your assets. Where are you, and should you maybe reinvent yourself in your business and look at it from a different angle and cater the needs of the next 12 years coming up. So when we look at our customers, we do have customers in air, in water, in wheels, underwater, under the ground, in hospitals and homes, in industries, in offices. So fundamentally, when customers are building embedded devices, they have the same software product development needs. I'm going to now look into that from 3 different angles on where we are offering solutions and how customers can find ways in the organization and in their effort and make things faster and more efficiently than before. So first of all, when you select your tools, you need to look at that. Is that a collection of libraries you found on internet, or is that actually a framework which is released as a whole and has the interoperability and all the bells and whistles that you would need to make your solution? A good framework is something that brings value for an individual developer, making them shine, making them being able to do more efficient work than what they would be doing without that. For a team, the benefits would be that it supports a collaboration, it supports working together, it supports the team, people swapping roles and covering watching for each other. And then for the organization, it provides benefits for making things more efficiently, improving the time to market and the total cost of ownership for creating the products. What's also important for you when you're selecting this is the maintenance, so and the product life cycle. So the Qt 5, at the end of Qt 5 has a 12 years of binary compliance, which is really rare for any technology in the industry. And we intend to make the Qt 6 as long living as Qt 5 is. And Qt has been there since last century, and we intend to be here also next century. So you want to look at that, does the vendor and the framework support the kind of product life cycles you are working into? And if you have trouble, who do you call? So can you actually get a business relationship and a support with the vendor? You may also want to look in that, do you have a vendor lock-in? So if for whatever reason the provider can support your needs, do you have the source codes, or do you have the freedom to go and talk to somebody else who can then cover the missing bits that you need for your solution? A good framework is also has capability of reusing existing talent. So if you have developers who know HTML5 and JavaScript, they already pretty much know how to write code in QML. As C++, Python are common languages. So finding talent who knows these programming languages is easier than if you pick programming languages that are maybe not so common. A good framework is also creating and opinionated in a way that it's enforcing structure and consistency for the applications on separating the UI and the application logic. It offers best practices and full end-to-end examples where you can reuse and learn and not to make the mistakes you would make if you didn't have this kind of ready-made solutions available. So that's about the framework part. Then if you look at what does this cross-platform framework mean for this kind of a traditional product company working on different products. So first of all, every single product has like an independent product would be a dedicated product team. They have their own specific tools for that product, that target. They are the company is looking into the profit and loss and the total cost of ownership of that product individually. They have their own competencies for using those tools. So swapping people from one product to another may be difficult. Each product is running their own roadmap and their own time to market. So if you need to do something across different products, you need like a coordination efforts and coordination teams. So if you look at this from a corporate CEO or a CTO point of view, you actually end up with an organization with different product teams running different products. And let's say the corporation would like to change something simple like a corporate logo and the corporate colors. And you need to do this by June this year. It's going to be challenging because it needs every product is working on their own life cycle and own roadmap. And every product has their own tools and technologies and ways of actually implementing stuff. So coordinating even simple thing like that may be quite a lot of hurdle, not to mention if you need to create like a new service element, you will need to provide corporate-wide through your different products. It becomes a hurdle. So this is where this kind of a cross-platform framework gives you a lot of additional benefits. So instead of structuring your organization the way on the left, you structure your organization the cute way on the right, where you create a single design, an R&D team with doing majority of the assets and the software, and then you have a smaller teams doing the deployment per product or the company and applications or internet HTML5 or WebAssembly targets. So that way your total number of engineers in your R&D organization is much less, and you can free those engineers to do something else in your organization, and then you get benefits on time to market, and so in the amount of time you actually spend on rolling out this kind of a coordination, so new features you need in your services. If we look at that in more detail how it works, so the team working on the Qt would be then the one doing the core of the application. So they would be doing the verification of multiple different reference devices, updating and creating the interaction model, any changes of that, design the user interface, adding the application logic, and then rotating on that and doing that for the service. So developing the main of the service on their own. And then there would be separate product teams that would then, instead of what they used to do earlier, like first select the hardware, then operating system, then framework, then do the UI, they would be then selecting the hardware and doing the design based on the actual needed software, and then deploy and verify that, and then manufacture and ship that. And if there are already existing products out there in the wild, there is a team for them to deploy and verify an update to the existing product, and then push it through the over-the-air update to the consumers. So this would create a lot of benefits on this kind of a multiple product organization, and this helps you in understanding how you can find and identify that kind of waste. Then I'm talking about the other way of looking, and this is the main theme of this event, of the developers and designers working together. And I'm sure you will hear the same story in a slightly different words and slides on other presentations, but still repeating it because this is a great area where you can also identify waste in the organization. So traditionally, the interaction designers and UI designers and developers are using their own different incompatible tools have their own favorite tools, and then animations and dynamic behaviors are described in text or in PowerPoints or in animated PDF files, so something to transfer the knowledge and information between these different parties. And then when the developer is getting the designs from the designers, he does some violence on that, on the actual coding it, and then sends the final UI back to the designers, and then they have to maintain the specifications because the implementation doesn't match the specifications. So this creates slow feedback loops, a lot of effort wasted and frustrated between these parties. But finding that may be difficult if you only look at this from the silo of these individual players on this game. You have to look at it from higher level and take a step back to understand that there must be a smarter way of doing this. I'm going to talk about that next. That was a good segue. So with the Qt tools, the designers doing the interaction designs, doing the visual assets, designing the navigations and transitions from different screens to another, are using their favorite tools, be that Sketch or Photoshop to create those applications. But then they import those into the Qt Design Studio. And the magic there is that whatever they are saving from Design Studio is the final UI code. So it's not the description or specification of the UI, it's the actual UI code in QML file that they're saving. And then the developer, when they're sharing the same repository, the developer can take that UI code and add the application logic into that, and whatever changes the developer's doing or whatever changes the designer are doing, they can both see each other those changes. The developer can then deploy that to a device and provide that deployment environment to the designer, and from there on, the designers can also see the actual designs on the actual embedded device. And that has a lot of value for designers because they can see that maybe the colors or the aspect ratio or the size of the elements or performance, what is working really nicely on their big desktop display, is actually not very good on this embedded display. So designers themselves can address the issues on performance or the usability of the application without the developer not even needing to know about that. And that way cut a lot of waste in the effort. Then there is a maintenance aspect of that. So creating a new versions of the application, spinning that to different products is something that this team can do, and the designers can look at them, all those different devices. And kind of like additional bonus benefit is because it's a cross-platform framework, the designers can save their designs maybe on a WebAssembly target, put it on the intranet, and then the higher management don't need to find that embedded device somewhere to see the UI and the application on the actual device. They can look it in their phone or in their browser in the intranet, and then give the feedback to the team that, hey, we want this logo to go that way. So that ends my presentation. So I was talking about the trends in device business, re-evaluate things you do, then a couple of ways of finding the waste in the organization. We, of course, have a lot of different other angles depending on the situation where you are in your own R&D, so we'd like to talk about that. And now it's time for you to jump to the Q&A session, and I'll be there answering your questions and answers. So thank you very much for spending these 24 minutes and 30 seconds with me. And I'll see you in the QA. I need to stop the presentation.